Let's give it a couple more minutes for people to show up. But the idea right now is take a quick scan through the article and identify a part you might want to dive into, then spend some more time actually reading it, since it's a complicated, long article.
Do we want to coordinate our sections?
I was thinking of that, but I suspect most of us will at least want to read the introduction and then just pick off the easiest section for us, since difficulty is a bigger constraint than divide and conquer. Right, let's do a quick round of shares of what jumps out at you and what you plan to read for 20 minutes. So I'll just kick us off. I think the part that interests me the most about the roadmap is the minor extractable value plans. So I'll be, so I think that's part 3. So I'll be trying to look for that. But in general, I think I'll scan directly start to finish, but spend more time on the MEV part. All right, who's next? Anuraj?
Well, there are a lot of words that I don't understand it, but I'll try to tackle the second part, history and state management. Next is Ben.
So I actually read all this yesterday. I didn't even realize this was going to be the thing for today. This has been on my list for a week or so. I could probably tackle any of these if you'd like. Maybe we can look at sort of the data availability sampling, the stuff that they're taking from Celestia, the KZG commits versus prod proofs. I can do that kind of stuff. That's probably harder for others.
Okay, yeah, sounds good. You should tackle the toughest part since you've already had one go through it. Grigory, I'll give you a minute since you just joined, but Jenna?
I think I'm the ELI5 of the team. I'll work on the conclusions chapter, and I dropped in the picture of the new Wired magazine, which is a Web3 cover, and it says something about, what are the hopes for normal people? This stuff is so complicated. If I can figure out what dank shard is, that would also be a small win for me today. Mayor?
I missed the first 3 minutes. So there's something different today, but I didn't quite yet understand what.
Just a very quick share of which part of this very long article you'd like to try and target, just to give a sense of what part everybody's reading. But if you're not ready, we can just go on to Nathan. And,
I just start at the beginning and hope it doesn't take an hour.
Okay.
But if you want to choose one for me, I will.
No, I'm leaving it up to people since it's a tough article. Nathan?
Well, I actually, like Ben, I read the whole thing last night because I'm such a slow reader. I thought I would need the extra boost. So I guess I will also, since I've had some familiarity, tackle the first part. Though I suspect that Ben, being more knowledgeable about the space, will have much better comments than I can. But I'll take a
All right. So sounds good. And Grigory and Mayor, since you came late, just take a couple of minutes to decide which theme or part of the article to focus on, and maybe spend more time there since it's long. But starting now, let's take 20 minutes to read the article as we like. And then when we come back, let's actually kick off with Ben and Nathan, since they've had the most time with the article to try and explain it to the rest of us. Then we can share comments. All right, so 20 minutes. It's 8:11 my time zone now, so we'll get the discussion started at 8:30. 20 minutes. Yeah.
If people could add some notes to the sections I've made, it would be nice. On the home page, I mean.
Okay, 2 minutes left, so take the couple of minutes to do your final scan and gather your thoughts, please. All right, let's get started, and let's do the order slightly differently today. we'll start with Ben, and Ben, if you could give us kind of like a 2-minute LE5 kind of like explanation, and then Nathan, you can go next and sort of add to what Ben says, and then we'll start with Anuraj and go down the list with just general comments. So Ben, over to you.
All right, sure. So I want to start at the beginning. The basic of a public blockchain is that you're generating economic finality, which is to say it's expensive to write or rewrite history. You also want what's global verification. In other words, you want to either check yourself or have someone else check that, be able to check that the system is working properly to enforce the economic finality. So this was originally done in Bitcoin. It was kind of done very naively. And eventually people ended up copying Bitcoin. And so we already live in sort of a naive multi-chain world. So what everything is trying to go do here, all this complexity, is an attempt to say, all right, we already live in a world with multiple chains, but we really want to be able to do better. We want to be able to tie these chains together so they can all share their economic finality, because that sort of apes together strong. The more economic finality you have together, the harder it is to rewrite anything. So you want to sort of merge all the security together instead of having little divided security realms where anyone can be attacked at a relatively low cost, even if the cost to attack the whole thing is high. If you can isolate something, you can just divide and conquer. So that's the attempt that all this is trying to do, is trying to find some way to tie the economic finality of basically multiple chains together into one big chain without running into the problem of, if you have to verify everything yourself, like only a few people in the world could do that with, big data centers. So this was attempted to be done very originally, and this is in the article, but they were called plasma chains at the start back in 2017, 2018. And basically the idea was, all right, well, instead of putting all the data on chain, let's put a hash and use a Merkle proof to deal with chain data. And they sort of ran headfirst into what now is called the data availability problem, which is, if you just try to do that naively, the person who is making these hashes, or who is actually having to deal with all this data in the back end, has a huge amount of power. So the whole idea around data availability sampling is to try to beat this data availability problem. And I'll just go very quickly, since this is so long, over what Ethereum is trying to do here, which is basically a two-pronged thing. You have erasure codes, and you have sort of proofs that the erasure coding was done correctly. Now, an erasure code is basically, you have a block of data, or blob of data. You use polynomials. You sort of encode the data into a polynomial. And the beauty of polynomials is that if you have a certain number of data points of the polynomial, you can regenerate the entire polynomial. I think you only need like half the data points that lie on the polynomial to regenerate sort of the entire thing. And the beauty of this is that any of the data points will work. So you're not like structuring the data points in such a way that like you need a certain order of them. Any of the half data points will work to regenerate the full blob. Now, this doubles the size of your blob, but that's okay. That's sort of like a constant factor. The basic idea is you encode the block data this way. Then you have the nodes sample very small bits of it. So your particular node might grab, a megabyte of a gigabyte block, or even a terabyte block, you could imagine, and just randomly grabbing little bits of it. And if there's, a million nodes doing this, the whole block is being sampled. And then why do you need these error codes? Well, the attacker, the person who's sort of generating this huge block, could generate the whole block, then leave out one tiny bit of it, sort of like a transaction that gives them all the money at the very end. And even a very large number of nodes might not notice that this little tiny bit at the end is missing. So you erasure code it so that basically, as long as half of the block is available, all of the block is available. And then the KZG commits, the Kate commits, or the fraud proofs are just there to prove that the data was erasure coded correctly. Because you're not actually analyzing all the block data, you're not sort of recovering it immediately when you do these samples. So they could just, fill the block with random data, or fill the erasure code with random data. And there's basically the fraud-proof way is someone checks the whole block, and then if it is constructed incorrectly, creates a fraud proof, warns everyone in the network, and collects a reward for that. And the Kate commit is sort of just cryptographically, you can prove that certain points lie on certain polynomials. So since erasure coding is polynomial based, you can just sort of commit that this is correct. So it's sort of like a zero knowledge proof. And there are different downsides to the various the commits versus the proofs. I'm not going to go too much into the detail there. But all right, I think that's more than 2 minutes, so I'll move on to the next guy.
Nathan?
I think that's probably a better overview than I had. I was basically getting hung up in trying to understand their data sampling regime there. And I think and so I was kind of trying to look at this. Anyway, I think for me, the key insight that actually just occurred to me as I was rereading it, or I remembered, and I don't think this does a very good job of highlighting, is what I think the reason this works is that polynomials are vectors. So you can take your polynomial and you can compress, and you can represent it, vectorize it, and so you aren't actually dealing with the polynomial directly the way we think of it. You're just going to operate in this space of polynomials, and you're going to operate on this vector, which is a single number. And so the whole idea of the different proofs was a little mysterious to me, and how you could do this without sort of knowing the polynomial. And it's still, I'll be honest, a little mysterious how you do the reconstruction. But I can see, since you have that vector, and you can always compress a vector down to a single number, you can do that sort of cryptographic proof on it. You can sort of you can hash that, you can sign that, you can show that is true, that polynomial was used without necessarily having to give a lot of information about what's going on there. I will say, if you're reading this and you are not familiar with some of these terms, I would recommend ignoring the polynomial diagram they give of the data and the extension, because as far as I can tell, it is completely misleading. Like, that is just not the polynomial they are describing is happening there. So I think that's really all I have to add. I just still getting my head around it a little bit, and what the sampling looks like there.
All right, now let's do regular comments, starting with Anuraj and going down.
Yeah, so I read the second part of the article, which is about history and state management. The summary is basically what are the current proposals to reduce the size of the chain, because if the chain size increases, then like normal people cannot have the enough hardware to run the nodes and clients. So it goes into the details of the current proposal that would reduce the size of the chain, and then there is also some discussion about reducing the gas prices. I didn't understand the technical part, but yeah, that is kind of the summary: how to reduce the chain size so that normal people, or we can achieve decentralization, and the other is about reducing the gas cost. Yeah. Next is Gregory.
Unfortunately, I tried to read a chapter, but I can't state that I understood it completely, and I don't want to bullshit anybody. So I will pass today.
Thanks, Greg. Yeah, my conclusions are I don't mind reading things that go way over my head. Part of why you guys are fun to hang out with. And I do think the general criticism of complexity is real, but it's not its own deal breaking because, of course, there are plenty of things in life that lots of people can't understand, and there are things that nobody understands, maybe even more than we even know, right? The unknown unknowns kind of thing. So, but I am really curious for you guys who are able to get into the weeds with this stuff a little bit, at least, to how do you see that evolving? So, 10, 20, 30 years from now, if this stuff survives and continues to morph into something that is in fact usable, how do you think about that, the complexity layer? Financial instruments that normal people can't understand have always been problematic. And with that, I'll pass to Mayor.
Well, I have to comment on what Grigori said, like what people say about quantum mechanics, that you can't both understand it and not be crazy. So this article feels similar. I only have a very shallow understanding of what's happening here, but I did start getting a feeling of the problems in blockchain, and I wrote some quotes that I saw in the voice meta. But if you remember, Venkatesh said that he feels that maybe going slow is a property, a feature of blockchain. And Ben said that you want it to be economically expensive to make changes, and I'm not sure if he said, and therefore to write. It seems like there's a lot of complication due to some sort of combination of that and fear of automated attacks. So in the attempt to make a system which is completely defined and completely automatic, you get something really, really slow, like, the computers on the space shuttle. In order to be reliable, they have to be very, very primitive. So talking about a block being 16 megabits, or that we have to wait 24 seconds to know what's happening, these numbers are not 2020. Saying that a blob is 125 kilobyte, that's not 2020. So I feel that this is going to have to change, as in break, because the world is not working in these small, slow numbers, and there has to be a solution which is not as problematic. On the other hand, it seems to me like as the nodes become more complicated, and they're trying to fight that, you get an oligarchy, like what we used to have with the cell phone providers. It used to be all the money was in the carriers until mistakenly they signed an agreement, AT&T did, with Apple, and now cell carriers don't make the money. Instead, phone manufacturers and app makers make it. Right now, the gas fees are, what do they call it here? Crisis. That's the word that they use. So I'm, by reading this article, I'm beginning to get a feeling of why we're in such a mess, but it doesn't look like it's going to get solved. Even all of these scaling solutions just mean that you can have more on the blockchain, but nothing modern. That's my takeaway from it. So, Venkatesh, you're next.
All right. So I tried to do a scan of the whole article. I also scanned it last night, but I was too zombified to actually read it carefully. And I did try to read more about the MEV aspect, which seems to be the current sort of pain point that they're trying to solve. So that's the minor extractable value, which is both kind of a feature and a bug, as in it's the incentive that drives the whole system, but it's also the thing that people try to game to get something for nothing. So and this seems to have like an interesting roadmap of how to do that. The proposer builder separation kind of addresses that, and then by the time you get to dank sharding, you have like more sophisticated mechanisms to it feels a little bit like whack-a-mole. Like when you think of an attack vector or vulnerability, you sort of create an architectural solution to protect against that particular vulnerability. It's not a sort of generic securitization of all possible attacks. It's securitization against like specific attacks people are smart enough to think of. That's the sense I got of it. But stepping back, the big question that was occurring to me is Bitcoin and Ethereum both represent philosophies of economics. And I'm starting to wonder who's actually more right about the economy. And if I summarize, it seems to me something like Ethereum's philosophy is the economy as it runs today. So the modern traditional finance economy with hedge funds and like financialization, all that stuff, they view that as kind of necessary, and they're trying to automate the whole of the economy as it exists now. So anything that can happen in the real traditional economy should be able to happen on Ethereum in a much more automated, fluid way. And they want to like make all that richness available. Whereas Bitcoin's philosophy is all this complexity that exists today is in some sense unnecessary, I don't know, fraud and capital capture or some kind of like unnecessary pathology, and the real economy should work beautifully in some sort of like libertarian Ayn Rand simplicity. So that's, I think, the reason Bitcoin is complex too. Like when I first encountered Bitcoin in like 2014 or something and tried to understand it, I did. It took like several passes before I could at least even pretend to myself that I understood it. But this is like 100 times more complex. So the question is, whose calibration of complexity of the necessary structure of the economy is correct? So basically, Bitcoin is like the economy only needs to be as complex as Ayn Rand Atlas Shrugged thinks it is. And Ethereum's philosophy is the economy needs to be at least as complex as it already is, and probably more complex. And I think philosophically, I agree with Ethereum. The universe does not get less complex. It does not stay at a simple level simply because we like it to. Life gets more complex, the universe gets more complex. So I believe the economy does too. So even though there's a lot of fraud and bullshit in the traditional economy as it exists today, I believe it's like closer to like 90% necessary as opposed to like 5% necessary. And to cross-check this intuition, there's this principle in systems theory called Ashby's law of requisite variety that basically says something like variety eats variety, or to manage or control variety, you need variety. And by variety, that's a technical term meaning just complexity, basically, you can say. So it basically says to control a complex thing, you need a complex system, which means if you believe the economy of like 7.5 billion people doing like a trillion different complicated things and trading with each other, that has a certain necessary complexity, and the thing that manages and controls it will necessarily be comparably complex. So that's kind of my broad sense of why I think, if this is possible at all, like putting the economy on a blockchain, Ethereum is probably more right than Bitcoin, but I'm not yet convinced. And same as Mayor, I think that there's like enough technical question marks. Like, yeah, this does add a lot more data capability and bandwidth than previous generations of blockchain. But is it enough to sort of like process the massive amounts of data the traditional economy already processes? I don't know. So lots of question marks, but there's enough here that I think if you were to like, I don't know, believe in this whole direction and say there's something here and you want to bet on something, I believe the opening statement of this report is basically correct, which is Ethereum is the only system actually tackling the whole thing, like the grand unified theory of the whole thing, actually tackling it head on. Everybody else is either like doing something simpler or drafting off what Ethereum is doing, or in the case of Bitcoin, I think believing in sort of simplistic fairy tale. So if you want to bet on this space at all, I think this roadmap is basically the only thing you can bet on. So yeah, those are my overall comments, and I'll probably take some time to try and reread this a couple of times and get a better understanding. But yeah, more comments, more thoughts, and especially more thoughts on like, in light of this future, what we at the Yak Collective should potentially do in this space. Floor's open.
One thing you did make me think of. So in the Bitcoin space, there is, don't know if you know about Paul Stork, or if I'm saying his name correctly. He is behind what's called the drive chain proposal. So there's sort of like this alternate Bitcoin universe of this whole sharding thing, and it's under. Let me try to just link him. I don't actually agree with him very much, and I don't even like him, but he does. Yeah, let me try to. I'll drop the link in the Rome. If you look up drive chain, he's the basic idea is, instead of dealing with all this technical stuff, just put it on Bitcoin and use basically economics to do this multi-chain stuff. And I don't want to go into it because it's another whole rabbit hole. But basically, there is sort of and what Venkat said about how it's a much more simplified, perhaps even delusional version of what Ethereum is trying to do. It's sort of like the Bitcoin version of this. And another interesting thing is that he's made this proposal like years ago, and it's never been accepted into the Bitcoin community. And honestly, if you want my prediction is that this will never actually come to Bitcoin. But I think that if you're interested in this sort of thing, you should at least look into him or this a little. Like I said, he's a pretty hardcore libertarian, Ayn Rand kind of guy. So I certainly wouldn't agree with him. But I do like pointing out this exists.
Just one. So people are trying to do something similar to Ethereum. I don't know if how there's something called Stacks token. They build like, I think, on top of Bitcoin, but what they exactly do, I don't know. But it's something like the layer two on people on Ethereum do. It's Stacks token is trying to do something. So I've seen people with handles similar to the ENS names. So they have like .btc addresses on their Twitter profiles.
So a question I'd like us to think about is, if the grand vision of like blockchains taking over the whole economy does not come about, is there still kind of like a stable futuristic subset that the blockchain economy will take over? So stuff that they can do, like, maybe it can replace the interbank settlement layer of international finance, something like that. So something to think about. And what room is there for, groups like ours, which you can think of as like transnational, small, unofficial, non-state groups. That's what we are. We have like people in like a dozen countries, and we kind of like act in a transnational way. And the bad version of that is terrorist cells and stuff. But the good version of what we're trying to do, is there actually a future here for us, a small future we can work with? So that's something I'd like to think about over the next few months, next cycle.
Yeah, I think my main I dropped some of my thoughts into the room, but I think, and I this is probably a little bit that I don't really understand the Ethereum internals, but there was something about this paper that really rubbed me the wrong direction that I have a hard time putting my finger on. And I feel like sort of my naive intuition is that this is not nearly as this is not solving the problems to the it's purports to be solving to the extent that it thinks it's solving it. Like it's ratcheting things up, but a lot of I think one thing we're seeing with blockchains is they're sort of the same effect as you see with highways. Like as soon as you build that capacity, you will fill that capacity. And it makes me wonder if this entire approach to scaling around a single chain is the wrong approach. And I also think that some of that may be my own biases, because sort of the naive thing that pops into my head is kind of the 19th century, proposal of how anarchist societies would be organized, of like hierarchical committees. And I'm not sure, like I just don't know, and I'm not. I also suspect that naive intuition does not actually work in this space. But yeah, there's just something about both this and Bitcoin where it just kind of feels like the one thing to rule the world, and I'm just not sure how well that works. And maybe the problem is the idea of finality. I wonder if part of the problem is that you can't just say we are at a state at this time, and accept that many things could lead you to that state. That to a certain extent, the past becomes as progressively unknown as the future. And I wonder if this sense of trying to preserve some of this, which this proposal is, or parts of what's in here are letting go. I do think it's interesting is that when they talk about data availability, they're like, well, we'll be clearing this off the nodes, but there will be other incentives for people to keep around things like this. And I'm like, if this is going to be around for 1,000 years, there are going to be missing blocks of data in this proposal. Like, I guarantee you that people are just not going to keep things around. So at some point you are just going to have, well, this was just the state we had at a certain time. And so maybe it's sort of retroactively finalized in that way based upon people just losing data, which is a lot of how history is finalized. But it does seem like if there's any advantage to doing things programmatically, it's potentially the ability to be more mindful about what we forget. And to a certain extent, what's the proposals about slimming the chain in here seem to be taking the opposite approach, throwing that to the wind. So I don't know. Those were just some additional thoughts that occurred to me as I was reading it.
I put in the Voice Matter an article by Brett Scott, who was mentioned last week. And he has a blog post explaining why Bitcoin is not money. And of course, he argues that crypto people are not willing to admit that. But if we're willing to accept what it says in the articles, then you don't expect the entire economy to be mirrored by some crypto, but rather that crypto becomes a useful tool in the economy. A slightly different way of looking at it. But I don't. Sorry?
Sorry, Mayor. Sorry, I thought you were done. Mayor, go on.
No, I just wanted to say that I don't know how that affects what the Yak Collective wants to do in Bitcoin, sorry, in cryptocurrency.
Well, just to riff off of that a little bit, this is like kind of what I was saying in the beginning, where I think that like the reason that I became more interested in this was when I began thinking of this as not a currency. Because I'll be honest, like if I think of this as simply in terms of currency, my initial response is like a lot of critics. I'm like, this is just a really dumb idea. Um, but if I think about it in terms of this is a distributed ledger, that this is like a distributed consensus ledger that I can just put things on, suddenly there's a lot of very interesting things you can do with that. To a certain extent, it's, to riff off of something that Venkat's been talking about in their newsletter recently. It almost forms kind of a log level reality for group minds, for coordinated systems, and that's a level of reality that's maybe not immediately as useful. Like, you still have to kind of go to it and figure out, well, what's the story of how this happened? Like A, then B, then C, then D doesn't necessarily tell me much, but it's a really necessary thing. And and the more I think about it that way, the more I think about it is you need like a currency for that to, I think, for the economic incentives to work within that. But then thinking about the currency as the thing that will replace currency is probably wrong. If you think about this as this is a ledger, then you're saying this is the accounting mechanism of the ledger. And to the extent that the economic activities are tied to the ledger, they need to be part of this accounting system. And to the extent that they don't necessarily need this ledger, they probably don't. And so I think it might, this is my bias, but like thinking about it in terms of this is a ledger with an accounting system attached to it rather than this is a currency, I think maybe gives us some spaces we can say, what are the ledger-like things that are useful to do here rather than what are the currency-like things. If I can.
All right. Yeah. So obviously more to digest on this topic than we can do in this hour, and we're already a couple of minutes over. But I think the reason I wanted to schedule this reading is it's a big roadmap article that forces us to think of some of the details. And hopefully it'll trigger some thoughts of what to put in the next cycle of meetings. So next week will be the last meeting of this cycle. Then we go into a summer planning meeting and we can sort of think about big picture what topics we want to get at. And incidentally, I know Brett's got personally a little, so I'll see if I can try and invite him to one of our future sessions to talk about his book. All right, so yeah, next week we'll close out this cycle and then we'll kick off a new one for the summer. So thanks, everybody.
Thank you.